Hello everyone, a very good afternoon to all of you. I am Priyanshi welcoming you all on behalf of SolarQuarter and Fortune Group to our webinar on evolving technology in DG applications in the solar energy sector. Thank you for all the attendees for joining us today. Hope you had a good time in networking. It is vital to understand the different technology trends in the distributed generation solar segment. To facilitate an open discussion pertaining to this, SolarQuarter is hosting a webinar along with Huawei and Elum Energy entitled Involving Technology in DG Applications in the Solar Energy Sector. Now, I take the pleasure to thank our sponsors, Elam Energy and Huawei, for extending their immense support to organize this event. Now, I request my team to start playing the sponsor videos of Elam Energy and Huawei.
It that takes us further into the future. It exists in every visible detail. And somewhere in the unexplored possibilities. We imagine countless times that dry deserts become lush oases. And now it has become a reality. Sunlight spur a new ray of hope. Make the earth green. And breathe new life everywhere. The size from rural to urban areas get simplified gradually. Conserve the nature and ensure seamless connectivity. Turning complexity into simplicity. Modular construction of data centers is designed for an intelligent digital world. To unleash cloud computing potential and to accelerate the smart future. Speed up for future transport. For every pleasure travel, green power is used to achieve an excellent experience. Modular power can be highly integrated and applied everywhere. To light up the moments you are looking forward to. Bring unlimited possibilities and make life better and convenient. Huawei Digital Power. Preserve Earth with technologies. For zero carbon, smart society.
In emerging countries, industrial and commercial buildings need a safe and reliable energy supply in order to manufacture and store goods or for the comfort of their customers. However, the daily blackouts of the grid can last hours, which is why they generally rely on diesel generators on site to ensure a stable power supply. This necessary power continuity is costly for business owners, as the energy coming from fuel can cost up to $1 per kilowatt-hour in some remote locations, putting pressure on their operating costs. Solar energy has become a great opportunity to reduce these operating costs, since solar prices have decreased when fuel prices were rising. That's why you now see many commercial and industrial buildings integrating a solar plant with their existing diesel plant. When a grid blackout occurs, the diesel generators start operating to power the building. Without a controller, the PV production stops. Thanks to Elum ePower Control HFS controller, PV panels can still produce energy during blackouts, while ensuring minimum genset loading and reverse power protection to avoid any permanent damage to the existing diesel plant. Elum e-Power Control HFS controller also complies with national grid codes through limiting energy exports to the grid. For bigger applications, such as power plants or mines, the hybrid fuel saver can ensure spinning reserve optimization to reduce plant fuel consumption. Elum HFS controller is compatible with all the main brands of solar inverters on the market through RS485 Modbus or Modbus TCP, but also with on-site gensets controllers, meters, or third-party sensors. It is fully autonomous, and its local intelligence allows it to store the data and operate the plant in case of internet loss. When the HFS controller is connected to the ePower Monitor web platform, site operators are able to visualize remotely all plant data, like power production and consumption, and to oversee the site operating status through logs and alarms coming from the diverse material on site. The ePower Control Hybrid Fuel Saver controller has already been implemented in more than 15 countries in the world, such as South Africa, Lebanon, or Madagascar.
Thank you, team, for playing the video.
And competitive controller for your solar and battery.
So now we will have a sponsor presentation.
Competitive controller for your solar and battery.
Sorry for the disturbance. Now we'll be having a sponsor presentation by Mr. Rizwan Razak, who is the CTO of Huawei. Over to you, sir.
Thank you very much. So I'll just share my screen if you just hold on 1 second.
Sure, sir.
So welcome everyone today. My name is Rizwan Razak, and my contact details are shared on the screen there. So welcome today. Today we'll be talking about the evolving technologies and specifically DG applications, where Huawei has had a lot of presence globally, and we'll be talking a lot more about it in the presentation today. So first of all, just to give everybody who is new to joining us today a background on Huawei and its organization structure. We've grown quite rapidly over the last 9 years, with the company achieving in 2020 above $136.7 billion US dollars. Now that is broken down into multiple different departments. I would say the solar inverter department is around 1% of the overall company structure itself. Now we are covered in over 170 countries, allowing us to have local presence and serviceable stocks, etc. And we have a large volume of R&D team members, around 53%. So everything that we are developing from our technology is all in-house and not developed or purchased from other brands. Now, coming into the solar sector specifically, I'm sure some of you are following the leader chart in terms of the market ranking of inverter brands, and you can see on the bottom right hand side, from Europe to China, we are very comfortably the number one brand of inverter. Now this has been ranked by third-party providers from the year of 2015 to 2020. 2021 values will shortly be released. Now, our equipment that we are supplying is able to accommodate for a wide range of environmental conditions, meaning low temperature, high temperature, high humidity factors. We're talking environments where there is salt, corrosion affecting products. And we have very comfortably supplied over 200 gigawatts of solar inverter equipment on a global scale. Now, one of the key reasons why we have continuously improved and innovated within this sector itself is our internal GC, Global Compliance Testing Center. So this is approved by a wide variety of global organizations such as TUV, UL, etc. So internally within our company, we are certifying and testing the products. Now, as many of you are familiar, we are supplying string inverter technology to the market. So from a product level, it's very easy to physically test modular units within test chambers, whether it is for EMC, whether it's for lightning testing, aging testing, or high temperature testing itself. And this is done very comfortably within our organization within China, and at the processes that we can follow are a lot more rapid for any recent changes that grid operators do enforce. So let's look at the next topic, which is the trends and the challenges within the sector itself. As we're talking about DG sector itself today, a large gap of power supply in the regions of Africa, for example, and around 11% of the population is still living in the dark environments. Now, we need to look and assess all the markets globally. So you can see around 600 million living in the dark, around 10 million in Latin America, 10 million in the Middle Eastern region. So if we break that down, there is quite a large portion where the electricity is not still touchable, and that electricity has to come from sources such as diesel from DGs. Now, traditional power is having a huge cost, specifically as was mentioned in the earlier videos today. The cost of let's say, oil is increasing on a global scale, and the construction period for building the utility grids in some areas is quite costly and quite lengthy in terms of time period itself. Now, looking at diesel generators, we're looking at the LCOE factor, which is around $1 kilowatt hour. Then we need to consider the population in providing that. So there is a lot of options available in the market, whether you want to look at utility or whether you want to look at just diesel generators. Now, today's topic is a mixture of both scenarios and how we can connect both applications into one and to reduce the effect of reliant on DG operations. Now, solar power generation is entering an area of parity. It depends on the market and region. So, for example, in the UK environment where I was brought up, you've got grid parity already occurring where the cost of solar has substantially reduced. So if you consider the cost of PV in 2009, and we now look at the PV cost in 2020, there's been an 86% drop. Now, for the battery technology, which will be another topic we'll be, let's say, talking a little bit more about today as well, to help in the structure of providing a more renewable energy source. That's also dropped by around 75% from 2015 to 2020. Now, as I mentioned earlier on, continuous innovation and leading the inverter brands, being a global brand for inverters for over 10 years, we've got a very comfortable status from IHS from 2015 to 2020 of around 23% market share globally. So let's go into a bit more detail about the topic of question today, which is the smart PV solution. Now, as Huawei, we will break down each scenario into different segments. So we talk it in regards to the larger utility scale plants, which are sub megawatt scale. Then we're looking at the C&I, commercial and industrial scale projects, considered from around 10 kilowatts going up to multiple kilowatts. And then we're looking at the residential applications where typically installations of around 10 kilowatts on average that would be considered. So I've broken down the demonstrations of DG and solar applications into 3 segments, and I'll be talking a little bit more about each one and having some calculations as well for everybody's understanding. So for a typical utility scale application, the architecture would look very similar to what you can see on the screen now. where we've got a PV mixture with energy storage system. And when grid is available, the complete system would be fed by either the battery power source, or alternatively, if the battery is not available, that energy would be coming from the DG, which will come into the next slide. So this is the key requirements, obviously, from the client is a guaranteed power supply and also a reduced power cost as well. So this is one of the options that is available, subject to obviously having the available land to install the solar and energy storage equipment. So the working mode with the mixture of all of these different sources of energy, either the energy would, let's start from the left-hand side, coming from the grid and going to the load, whilst if there is enough power coming from the PV, that would also be providing power to the load, and also any additional power going to the battery storage itself. Now, if the grid was not available, the option would be to supply power from the PV and the battery, subject to the battery being available. Now, if the PV is also not available due to a cloud coverage or not enough irradiation, then the energy would be coming from the grid. And on scenarios where PV is not available and also grid is not available, then the reliance on the battery technology would be implemented. Now, on certain scenarios, let's say where existing infrastructure of DG equipment is already available, then on scenarios where the grid is not available, PV is not available, and the battery is also out of use, then the DG option would be incorporated. However, the right calculations need to be done from day one, not just based on a continuous average load, and we need to consider forecasting energy for 5, 10, or even 20 years to ensure that no limited use of the DG is incorporated into the projects themselves. So here is a project that we have in Africa, where it is divided into 10 projects themselves. The total PV capacity is around 10 megawatts. The total BESS capacity is around 20 megawatt hours. And this was a mixture of DG equipment, so diesel generators, PV, along with the PCS for the energy storage as well. So this was trying to minimize the usage of the diesel and having a more fruitful energy source for the project itself. So another project in option 2 here, we have 10 smaller projects across the project itself. So rather than just being concentrated in one location, the energy storage along with that is divided into 10 different locations of around 2 megawatt hours each. And the usage of the DG was eliminated in this scenario. So it really depends on the client's requirements and the existing equipment that is available within the project itself. Now, for calculation purposes, I think this is quite an important slide for everybody to really understand and how to calculate it correctly. We can do this face-to-face or in a workshop directly, but for everyone's case, we've analyzed here the usage of PV and energy storage and the breakdown to that, along with the DG cost itself, and with a mixture of both of those operating, the year of when the solar system would be more applicable is shown on the right-hand side, comparing both applications from the first year all the way to 20 years. Now, let's look into a case for a multiple kilowatt system for a commercial application. Now, here is an example structure of the hybrid solar solution that is applicable. So these are typically 400 volt applications where the PV system is connected to either multiple inverters or just one 100 kilowatt inverter, for example. That's then connected to a distribution board. Your distribution board is fed with power from grid and also the DG. So if the DG is not available, then the grid would be supplying the power. If the grid is not available, then the DG would then kick in to provide that stable voltage and frequency source. Now, from the load perspective, you've got whether it's gas stations or shops or multiple other lighting sources, that would all be fed from the DB. Now, the key criteria here, the reason why we've collaborated with one of our partners today, Elum, is there needs to be a control mechanism in place for these types of applications. So when the grid is not available, the DG needs to be instructed that there is a loss of connection between the grid, and that power then needs to be relied and coming from the DG or the PV system itself. So we've done a basic calculation here. So the simulation parameters are shown on the top left-hand side. So a standard clear sky example has been incorporated. You need to consider the type of modules, the tilt angle of the PV modules themselves, what angle due south that you're considering. And then historical data is quite an important factor for the irradiation purposes and to estimate your energy production daily, yearly, for your future generation and estimations that you would be considering. Now, from a PV system perspective, what we've calculated here is around 200 kilowatts system with the PV modules are around 200 kilowatts as well. From the genset perspective, we've got a rating of 250 kVA, around 200 kilowatts, with a minimum loading of around 30%, as this is an important factor to consider when calculating hybrid projects, as there needs to be a minimum load from the DG. So this will incur fuel costs and O&M costs as well. So that is shown in terms of its consumption price, so 3.2 AD per litre. And then from the energy storage parameters perspective, around 125 kVA battery output of around 100 kilowatts, and the capacity for the energy storage is around 500 kilowatt hours. So other factors to consider for the energy storage perspective is your state of charge, the state of health, and these factors need to be considered correctly in your total calculation. Now, there is multiple different softwares available from the hybrid controller companies like Elum as well. And here is just one example taken from the top right-hand side, the current daily load profile. So we need to consider that in the calculation purposes. Now, the daily load profile shouldn't just be considered from a one random day. We need to analyze the maximum load ratios and the minimum load ratios in order to calculate exactly how much saving can be produced for the end customer itself. So on this example, there was a saving of around 1,290 AD, and there's around fuel consumed, and it is around 199 liters. As on this type of application, the requirement for solar plus energy storage plus DG was what was required on this particular example project. Now, I'm just trying to run through the slides. I know time is quite compact for my time slot. So just for the residential applications, there is a couple of options that we can provide. But for the residential applications, we have got a solution for the smart string ESS equipment. So no matter whether there is a blackout or outages within the application itself, the solution that we are providing will be able to supply that power source. Now, here is a simple example of the type of application where we are suggesting the iPower Cube equipment. Now, that iPower Cube is your total turnkey modular unit, providing the power module along with the battery module in modular 5 kilowatt hour units. So you've got the grid connected to the AC distribution board, you've got the DG connected to the AC distribution board, and then we've got the PV from the roof area also connected directly to the iPower Cube device as well. So on certain scenarios when there is no grid available, then the DG would be operating at minimum load, and the iPower cube will be able to supply the load from the battery or from the PV equipment itself. So there's multiple different examples of applications that this can be installed on, from outdoor working environments, emergency rescue areas, shops and restaurants, houses and apartments, and government enterprise outlets as well. Now, one of the factors to consider is the equipment that you are considering. As I mentioned earlier on, is the environmental conditions. So typically in residential applications, people don't want noisy equipment. So from the iPower Cube that we are suggesting and recommending, it's got a noise level of less than 29 decibels. And from a indoor or outdoor deployment application scenario, the product is coming fully IP65, allowing there to be multiple different usages, and this can be installed in garages or outdoor areas themselves. So here is a clearer example with a breakdown of the calculations on the right-hand side. So as I said, the power module is your top device in a modular unit, and then you've got 3 times by 5 kilowatt hour units. Now, it doesn't come as one complete package. If a customer requires 5 kilowatt hour only of batteries, it can also be supplied, or alternatively, we can daisy chain multiple of these up with a maximum of 3 into one power module of 6 kVA. So on the right-hand side is a breakdown of the power capacity from the PV side, and from the AC power output. Typically, this is provided for single-phase applications, which is quite common for the residential projects themselves. So just to give a clearer breakdown of how the formation of the electricity would be provided on a 24/7 power supply system. DG operating, that would then supply some of that power going to the load, and that would also, the solar part would also go to the battery. Within 10 milliseconds, if the DG and the grid was not available, then the solar or battery would be able to supply that power. And on the right-hand side, at night time, your power is either coming from the grid or DG, or alternatively coming from the battery, depending on the load profile and the battery storage capacity. So just to kind of conclude on my slides, we've got multiple different success cases that are already deployed. So here is a project in a very rural area in Africa, where we've installed around 25 megawatts of capacity and 60 megawatt hours of ESS. So the benefit here, it's produced around 32 million dollar saving. In terms of benefits, new jobs in the environment, a reduction of around 30,000 tons of CO2. And this was done in multiple different phases, and is actually still under development in 2022, and it's ongoing till 2025. Another project in Nigeria. I think some guys have also joined from the Nigeria area within Africa as well. So this is a project of around 1.5 megawatt capacity in terms of solar, and around 4 megawatt hours of energy storage. So there's around 30 distributed sites, and as you can see here, it's implemented within a container facility for safety and also for temperature control of ESS and the solar equipment itself. So this is benefiting by providing around 6,000 houses, of accommodation within Nigeria itself. Another project in Lagos, where due to an apartment building, so they're providing, let's say, solar to that would be only accessible from the rooftop area. So the system is a lot smaller, around 120 kilowatt peak, with a inverter capacity of around 72 kVA. And the lithium ion batteries are around 96 kilowatt hours, with backup of up to 2 hours supply. Now, the grid within the city itself is quite stable, but there is times of grid outages where the genset device is also incorporated. So going into the kind of solution values, there's around 303 kilowatt hours of daily power generation coming from the solar equipment, and we are saving around $20,000 of the cost of oil for the project itself. So for a rooftop project on a residential application, as we showed on the last part of the presentation, we can also assess and recommend solar applications and in terms of doing the breakdown of the initial investment cost, looking at the annual energy yield for the project itself, and based on the annual electricity energy bill, we can also work out the ROIs. For this particular example was around 8 years. So another project in China, this is around 32 kilowatt peak with around inverter capacity of 18 kVA. There is no access to any grid here, and it's completely reliant on gensets. So the usage, and with the increase of oil prices specifically, there was substantial saving achieved here, and in terms of investment, the multiple sets of power was able to save substantial amount of money for the client, and this was completed around 2 years ago in 2020. So lastly, just to kind of demonstrate our manufacturing facility in China, in Shenzhen, this is the rooftop area installed with around quite a large capacity, and the payback period was around 4.2 years for phase 1 and around 5.1 years for phase 2. Thank you very much, everybody, for listening to the Huawei presentation. This is the Digital Power Department, and as of the end of last year, we have very successfully supplied around 470.2 billion kilowatt hours of of green power from our calculations, and that's equating to around 310 million trees globally. And I'll hand it back over to the team. Thank you very much, and I'll be happy to take some questions on the session later on.
Thank you so much, sir, for this insightful presentation. After this, we will After this, we'll proceed with the sponsor presentation by Mr. Rawat, sir, from Elum Energy. Over to you, sir.
Hello guys, so thank you Rizwan for this presentation. Let me share my screen. Okay, is it visible?
Yes, sir.
Okay, great, thank you. So first of all, thank you everyone for joining this session. So from my side, as you may know, I'm Rawad Yusuf, Sales Manager for Elum Energy, responsible of the EMEA region. Basically, in this presentation, I'll be discussing the core business for solar, diesel, and BSS hybrid systems. So first of all, I'll go for an overview of our company for the guys who doesn't know Elum Energy. Then I'll discuss some PV diesel hybridization systems, our product portfolio, and finally some references. So Elum Energy is a French company based in Paris, France. Our core business is the monitoring and control for hybrid and microgrid systems. We have projects, so over than 500 sites already installed in more than 40 countries. Our main clients or partners are the developers, IPPs, EPCs, and sometimes some equipment manufacturers like Huawei. Our business is divided into three main sectors: the power plant sector, the microgrid, where the battery storage is available, and some rooftop solar for C&I buildings. One of our added value in Elum is our compatibility. So we're compatible with a lot of different brands. Here you can see some examples. So in terms of inverters, you can see Huawei, Sungrow, SMA. In terms of genset controllers, you can find Deep Sea, Comap, Woodward. And also we're compatible with different equipment, so different brands in terms of PCS like Synaxel, Tesla, and Kewa. We're not tied let's say, brands, we're flexible in terms of compatibility. What we ask for is to use Modbus protocol for communication. In this presentation, I'll be discussing two types of projects. The first type is the pool grid and totally off-grid. This is basically the project that we face a lot in the MENA region. So starting with the pool grid, basically the main output of integrating the PV with the diesel genset is to reduce the fuel consumption, to reduce the greenhouse gases emissions, and for sure to increase the penetration of the PV production. Going briefly about the system, so you can see our controller will be installed, connected to the different equipments, as Mr. Rizwan gave some example regarding PV diesel hybridization, where you need a controller in order to manage and provide some features. So the controller will be connected with the grid side to provide the grid feed and management. So either the zero export or the net metering, depending on the country and on the project. And once there is a switch, once there is a blackout switch to the backup genset, the controller in that case will provide the minimum genset loading. And in that case, we will be reducing the fuel consumption and increasing the PV penetration. I want to mention here, so since we are connected with the different equipments, we have also our monitoring platform, so we can retrieve the different data from the different equipment, and you will have a monitoring platform showing all the different energy sources in the system. Basically, this is what I explained in my previous slide. So with this PV diesel controllers, we provide the grid feed and management and the minimum genset loading. So going to the off-grid side, so here you can see an example where you have a genset plant, PV and BSS system. In these cases, we use our microgrid or PPC controllers, and we have basically the same concept. The controller will be connected through Modbus with the different equipments and will able to provide several features. These depending on each project by project. So how the client or let's say the APC wants to manage the system. What we provide is this energy management system that can manage between these different sources. For sure, with our controller, with all of our controller, also you will have the e-power monitor, so our remote monitoring platform. Going for some examples of what we provide with these controllers. So you have, for example, the spinning reserve optimization, either from the BSS part or the genset part. We provide for sure the minimum genset loading, and in some cases the diesel off mode. For sure, if the equipment available on site can let's say change the grid forming units. For example, the BSS can be the grid forming unit of the whole system. Then we can turn off completely the gensets in order to reduce the fuel consumption as much as we can. Here are some applications that we face in the Middle East region, such as agriculture, reliability, and oil drilling application. The main, let's say, output of this application or the client's needs, as I mentioned, to reduce their fuel consumption, reduce the greenhouse gases emissions, and at the same time increasing the renewable energy penetration, either from the PV or the BSS system. Now, going through our portfolio, you can see we have different families. So I'll go through them quickly. We have the first family, which is the solar diesel, or known also as hybrid fuel saver. With this controller, it's the first case, the pool grid. We installed these type of controllers to integrate the PV with the diesel genset and make sure that the genset is running at its minimum loading, let's say to reduce the fuel consumption and also to reduce the maintenance problems that is happening with the gensets. The other family is our microgrid. So this ES falls under our microgrid systems, where we use these type of controllers in order to integrate PV BSS systems or storage systems. These ES and ES Plus were launched around 2 months ago. Basically, it's meant for projects, for small projects, up to 200, 300 kilowatt hours with one or two gensets. Basically, with these, so they are smart controllers where you can install them. They have, let's say, the flexibility in terms of compatibility, and at the same time, where you can manage and change the feature, choose the features needed for your site. This is the MC in general, so our MC product, so microgrid controller. This is also basically for sites up to 1.5 megawatt, where you have some advanced, let's say, control strategy and additional features than the ES, such as breaker controls. And finally, we have our PPC, power plant controller. This PPC is meant for multi-megawatt projects and complicated projects. Also, it is used for grid-tight application, where the clients ask us for active reactive power control, or basically dynamic control of the cost fee in order to be compliant with the grid codes. With all of our controllers, we have this configuration platform. We call it eConf, which will be a very easy, or let's say simplify the commissioning of our controllers. You have to follow several steps in terms of connectivity, choosing the controller strategy, and for sure this configuration platform will lead to our support team to access the controller and help you step by step in order to commission the controller. Also, as I mentioned, we have our monitoring platform. So this is some screenshot of what you can monitor remotely. You can see we can have a tab for each energy sources, either BSS, PV, genset, or utility grid. In addition, I want to mention for the PPC for power plant controllers, we can also provide a SCADA system. These are some screenshots where you can see synoptics of the sites and have the ability through an HMI available on site, the ability, let's say, to control some breakers, to change the control mode available there. Going with some references. So at the beginning, I'll mention some references with Huawei for the solar diesel part. So you can see we have several projects in Pakistan, Kenya, and in Yemen. There is different, let's say, sizing and different number of genset integrated. Here you can see 2 genset, 1 genset, or different gensets. With these type of projects, we use our solar diesel or hybrid fuel saver controller. Also, on the utility scale part, we have this project in UAE for 2.2 megawatt, 1 megawatt hour of batteries, and 4.5 megawatt. And finally, for the MC controllers, we have this project for the water bottling facility in Cambodia, where we integrated 650 kilowatt of PV, around 900 kilowatt hour of batteries, and 2 different gensets. Going with other reference briefly, so for a utility scale, we have this project in Somalia for 2.2 megawatt, 250 kilowatt, and 3.2 MVA of gensets. Also, I want to mention for this project, so you can see here we integrated the hydropower unit. This is just to show you that we are not tied only with the PV production or PV energy source in general. We also have this flexibility to integrate other renewable energy sources. These also some example of storage project where we used our MC in Puerto Rico and in Malawi. And finally, this project, so in Puerto Rico also, where we integrated the 50 kilowatt, 170 and 300 kVA of gensets. I want to mention also that the application of our MC products, or that, let's say, the different controllers can be on-grid or off-grid sites. We're not tied of the on-grid side, so we can manage both type of projects. Thank you for your attention. So if you have any questions, please feel free to contact me. Also for any inquiries, or if you want to for any support for any specific project, I'll be more than happy to help.
Thank you so much, sir, for your insightful presentation. So now it's time to begin with our much awaited panel discussion, which is on the evolving technology in DG applications in the solar energy sector. And to discuss this, we have in the panel with us Mr. Sameer sir, who is an independent engineer, Mr. Rizwan Razak, who is the CTO of Huawei, Mr. Rawad Yusuf, MENA Sales Manager from Elum Energy, Mr. Syed Asad ur Rahman from Jubaili Bro Solar, who is the Group Production Manager of Renewables, Mr. Walid Al Halaj, who is the Business Development Manager of Jinko Solar. I would like to make a small announcement here. All the attendees can pose their questions in the Q&A box. Now I welcome all the panelists on the screen and requesting Sameer sir to lead the discussion. Thank you so much.
Thank you very much, Priyanshi. This fantastic support. I would like to start with our silent speakers. First, Mr. Syed. Mr. Syed, a short bio. He has an electronics degree since 11 years. He has extensive experience in renewable energy, which include hybrid microgrids, energy storage, and commercial and industrial solar. He's working as the group product manager for renewables at Jubail Brothers for hybrid and renewable products identification, R&D, testing, and rollout. He is also the managing products rollout through branches and dealer network for markets such as the GCC, Africa, Yemen, Pakistan, Iraq, and Afghanistan. Very proud to have you with us, Mr. Syed. And I'd like to start with a question. From your experience, how are the diesel generators are getting replaced by the PV and with storage?
Thank you, Samir. Thanks for having me on the call. Just a brief introduction about the company. So I'm from Jubaili Bros Solar, and we are basically the genset manufacturer. Also, we do the distributed solar, hybrid microgrids, energy storage system. We represent in this region Huawei and also Jinko. Huawei for the inverters and the storage, and Jinko for the solar modules. We are a company which is 55 years old with around 20 gigawatt of generator set installation. Also, we are very active into the hybrid microgrids, energy storage, and also the on-grid PV systems. So as Samir asked about the current situation with the hybrid microgrids. So as we know, like the fuel prices with the current situation, and also like in the past, has continued to grow. As the fuel prices are growing, and on contrary, the price of the solar panels and especially the storage is also going down. So it's considered as a right time for any project hybridization, which primarily is using the diesel fuel as a source of energy. Also, the thing is like as the market, like for example, there are the certain places where you do not have the energy sources, or you don't have the utility power directly being connected to the the consumers. So they're also I say that whenever the customer is using the diesel generators as a prime power source, there is always an application of a hybridization. And as the renewable cost is going down, the controllers are becoming more and more efficient. There is a huge demand of the hybrid microgrids, which is picking up.
Okay. Thank you very much. I like now to ask Walid, Mr. Walid Hallaj. He's a dear friend. He has around 10 years of experience in engineering, development, construction, and manufacturing of solar PV. He's also a recognized professional with the Association of Energy Engineers. He has 3 certifications, CEM, REP, and business energy professional, and he was chosen by the association as the Young Energy Professional of the Year for 2019 for the Middle East region. He oversees the Middle East region and North African markets as the business development manager at Jinko Solar. Very proud of you, Walid, and I'd like to ask you about the new markets where Jinko Solar started the storage. So do you see a demand on the solar PV and plus storage replacing the diesel generator in the MENA region? Thank you.
Thank you, Samer. Thank you, Huawei Elum, for the invitation. Very happy to be here. As you can see, I barely have time to get a haircut. This is how busy we are in the industry these days. It has been hectic few weeks, and I think my colleagues here all agree that the demand has spiked like it has never did, basically because oil prices shown again that you cannot depend on them at all. And this is moving the market in both the on-grid connected and high demand for our solar modules for utility scales or microgrids, and also to replace oil generators or diesel generators, basically with the PV plus storage. I'm not going to discuss the PV plus storage. I'm going to leave it to the gentleman from Huawei, but basically for the module, for the new technologies, for the extreme demand in these 2 segments, we have seen a few problems that could actually be started to show actually, which are basically the supply demand equation. I'm not sure if other industries are going through the exact same problem, but for solar industry, I know for sure that the extreme demand is causing some pressure on the supply. And this is all because of the extreme new demand that is raising in the region. We have seen there are markets that have been on for a long time, like Yemen, like Iraq, and now there are few new markets that are kicking off into the equation. I'm pretty sure Huawei's team or Elum team are also familiar. We have Lebanon today. Lebanon is going towards solar like never before. And this is all good. This is all in the right direction. And you can even actually, Samer, I know you try to follow a lot of the news. You can see that even countries, even governments are switching their strategies to focus more on dependence, because now electricity is becoming not a commodity, it is becoming a national security issue. So it's good times and pressure times with markets pretty much everywhere.
Thank you very much, Walid. Yes, definitely. Actually, the oil prices are skyrocketing because of the geopolitics in the continent of Europe, and it's affecting the rest of the world. It's also affecting the supply chain. So, my next question is for all of you, is to give us a brief input from your perspective about the current rise in oil prices and impact on the supply chain of the solar PV products. So I'd like to start with Mr. Razwan. Mr. Razwan, are you hearing us?
Yes, I can hear you very clearly. Thank you. So,
Excellent.
This, being a large organization such as Huawei, we are able to, let's say, suffice with a lot of implications such as oil prices, etc. However, let's say when it comes down to logistics, we've seen that the transportation costs, specifically of taking equipment out from China, has risen quite substantially. So that's affecting financial models of particular projects. And other factors are the supply of the internal components themselves as well. So items such as from the battery market itself, from projects that were designed and developed and signed, let's say, a year ago, there has seen a development in terms of the prices there as well. So it is shifting, it is changing. We try to adhere to a lot of our customers' requirements. If there's a contract that is signed prior to the prices changing or fluctuation, we will have to adhere to that. So would like to just mention once again here that if there is anybody that has projects and thinking of delaying them slightly, do consider that obviously there is a lot of changes happening in the market, and these will only increase. It's a very small chance of it coming down again, but this is affecting everybody from module supplier to inverter suppliers to the EPC contractors as well.
Thank you very much, Rizwan, for your insight. Same question for Mr. Awad. Mr. Awad, your insight, please, about the impact of the fluctuation in international oil prices on the logistics of supplying solar PV plus storage on the projects. Thank you.
Thank you, Mr. Samir. To be totally frank, I don't have, let's say, a big idea regarding this point. We're not totally affected. What I can say, so directly affected, but I can say that basically, as Mr. Rizwan mentioned, we had some delays in several projects in terms of, let's say, BSS systems. So the delays is becoming a bit harder now. So we have more delays regarding the supply of these projects. And this also delay our projects, so the projects from our side. We're not directly affected, but we're affected by the delays happened with the EPCs, with the developers. So this is the situation now.
Thank you very much, Mr. Rawad. Mr. Syed, with your big network of dealers and different products, are you seeing any impact on the cost of logistics and doing business due to the rise and unpredictability of oil prices? Thank you. Mr. Syed, you are on mute.
So basically, this is the day in, day out topic in the organization at the moment. We have been struck a little bit hard with the logistic issues. We are the largest buyers of Perkin engines. And as the material prices are going up and due to the logistic issues, getting the material in time, we are facing the challenges in terms of the supply lines, given the fact that we were preempting it. And we had placed large amount of orders, but still we are facing a lot of issues. Coming to the other part of the discussion, the oil prices. Like we have seen the time when the crude oil was in the range of $60 to $70. And at that point of time, we were talking about 5.5 years of the payback on the hybrid microgrids, simply the PV diesel hybrid. Now, since it has jumped above $110 a barrel, so you can see that the demand is getting aggressive, and as well as the ROIs are shrinking up. So a lot of factors are affecting, and then of course due to the logistics, as the prices are going up. The getting the material in time is a bit of a challenge. I also want to put a certain light on current situation with the crisis in the countries across. Especially Walid was talking about the Lebanon. Like we are seeing the demand in Lebanon that was never been before. It's like skyrocketing. Whatever material you have, whatever the solutions of the renewable equipment you have, especially the batteries, the PV panels, they are selling like a hot cake. So I haven't seen during my career such a high demand and everybody will gonna be agree with me. Like this is a crazy time, and this is the right time for this industry to grow.
Thank you very much, Syed. Mr. Walid, please, can you share with us your insights about the fluctuation in international oil prices and the impact on logistics and orders, PV orders, storage, and so on?
Thank you, Samir. I'm gonna repeat what Rizwan said. Yesterday, I was attacked in a conference because I openly said that people should stop to wait for prices or circumstances to go back like they were 18 months ago. And this is a fact that many of the companies, many of the stakeholders, many of the financing institutions started to understand. This is why the demand is also expanding on many cases. We see news that many of the pending projects, the utility scale pending projects, are going back. Although now prices are high, although now logistics are high, I think, Samir, this is the new norm. This is the world that we're going to live for a few years ahead until things get back on track. And if I focus again on the solar modules, again, for 2022, the demand is expected to exceed the supply massively. Last year, we had a huge problem with polysilicon. This year, we have a problem with EVA and encapsulant. You can only imagine that a day will come where glass is going to be a challenge. This is a massive industry with a massive demand. And to be honest, one thing that I have noticed that even though, by the way, Jinko Solar has expanded from 25 gigawatt a year to 45 gigawatt a year. So almost we doubled in size, and still we are facing a problem in being able to satisfy everything because, you know, especially in this region, everybody wants their product yesterday. It's not even after a week. And I think this is now the new normal. The fact that we used to pay $1,500 to ship a container from China is gone. It's not going to happen for a long time ahead. And this is why the market is kicking off. And I think big companies will have to adapt with that.
Thank you very much. And I also remember seeing a presentation by Jinko. At one point in time, you were going up to 70 gigawatts. So I'm not sure which year, but
we actually before 2 days we celebrated being the first company in the world to supply 100 gigawatt in total shipments. So
well,
100 more, inshallah, very soon.
Definitely, we need that. The second question that I would like to ask all our speakers is about the levelized cost of energy. So in 3 to 5 minutes, can you explain how do you calculate the levelized cost of energy in a volatile market right now? And have you resorted to hedging? Mr. Rizwan?
Yeah, so we this is a daily discussion from Huawei side on topics when we are working on projects with developers and EPC contracts, etc. So LCOE, as we all can understand, is a capex calculation, also considering the factor of OPEX, and then also calculating your energy that will be produced during that period of that project itself. Now, as we can all understand, you can potentially bring down the cost of equipment. However, that could factor in additional OPEX cost and also be impacting your yield as well. So this is quite a good question that was kind of asked, where we have that advantage value and we really work closely to the customers to ensure that this value is provided to its, let's say, detail. So from a product level perspective, having a product and testing facility within China where we can test environmental conditions in low temperature, high temperature, for example, it has and adds that benefit value there. Then looking at from a solution aspect perspective, the features that are incorporated, there used to be 10 years ago large centralized inverters of around 200 kilowatts. And now we are seeing in the market 200 kilowatt string inverter technology, modular, which a single person can potentially lift and mount onto the structure itself. So technology has moved quite rapidly, but also I think one of the things that we need to support in the market, especially in the Middle East and Africa market, is the development of understanding and educating the market for what these changes and values are bringing to the solar projects themselves. So that's one of the reasons today why we helped, we're working with Elum Energy and the other partners to really make the market aware of doing the calculations correctly. I showed in my presentation earlier today some basic calculations for the utility scale and for the residential and commercial applications. It's very important to do an assessment to a high level of accuracy to really incorporate the right product and power flow sufficiently. As adding additional components at a later stage could incur more costs and impact the end client quite substantially.
Thank you very much, Razwan, for your insight. Same question for Mr. Rawad. Mr. Rawad, regarding the levelized cost of energy and the in this market, in this volatile market, how do you approach your customer? How do you calculate? How do you convince your customer for with the levelized cost of energy?
Yes, basically regarding, let's say, the calculation, Rizwan mentioned it. So the importance is the accuracy in that. I will not add regarding the calculation, but I want to mention some points that will play, let's say, a big role in this calculation. So all the clients or the IPCs also should know that it's not, let's say, a straightforward calculation. There is a lot of different factors that comes into this let's say calculation, if I can say, like the fuel pricing, the load variation, also the design, which plays a big importance. I can give an example regarding this point. So we faced a lot of different projects where they want to integrate this PV system with their all the gensets, but some gensets sometimes are oversized. There is some let's say bad design from the beginning. They didn't monitor the load. They didn't check how the system was behaving before, and they installed some equipment that are not, let's say, basically right for the system. And this also plays a big role in terms of let's say levelized cost of energy, because while integrating the PV, and at the same time we want to have some safety for the genset to reduce the fuel consumption, we cannot work in, let's say, in a bad design, and this is why we need more people or more trainings regarding these points in order to have the best design for the system.
Thank you very much, Rawad, for your insight. Highly appreciated. Now we come to Mr. Syed. The same question regarding this levelized cost of energy. When you convince when you want to convince your client of this product that you're selling, and you present the levelized cost of energy, and this is changing up and down in this fluctuating market, how do you approach this problem? Thank you.
Actually, the levelized cost of electricity, as Rawad and Rizwan was mentioning, it's a very wide term, especially in the hybrid microgrids or the PV diesel hybrids. It depends on multiple factors. So when we approach our customers, we approach with a proper analytical way. We try to assess the load profile of the customer vis-a-vis what is his genset, what is the type of the genset, type of the fuel, what is the cost of the fuel, maintenance intervals, what is the top and overall, major overall intervals. And based on that, we suggest him either he has to go with a certain amount of PV to get how much percentage of the saving, which we call the PV penetration. And similarly, we have to assess either the integration of the battery versus the load requirement. Is it worth it? It's not worth it. Based on all these assumptions, we get the net present cost of the for that customer, which depends on all these multiple factors. And there is always a sensitivity factor, we call, which is the variation in terms of, all these costs, once you have, there are certain variables which keeps on moving. variables in a sense, like the cost of the overhaul can go up and down, the cost of the repair of the genset can go up and down, and the cost of the diesel fuel can go up and down. So these variables keep on changing. So our levelized cost of electricity should be projected. It shouldn't be fixed. It should be projected, given the customer that, okay, if the fuel price is this, you get this LCOE. If the fuel price will jump to this, your LCOE will increase by a certain percent. Similarly, the sensitivity factor apply on the maintenance of the gensets, as well as the spares or the overhauls. I hope I have given you what you wanted.
Yes, thank you for your insight, Mr. Syed. Definitely presenting the customer with different scenarios is one of the options. And true, the sensitivity analysis is very important. Highly appreciated. We come to our dear friend Walid. Walid, the levelized cost of energy is very important. It's related to the amount of energy that your PV modules are generating, and the savings that depend on the cost of fuel. So how do you let's say deal with the customers under these circumstances with the fluctuating oil prices?
I think with fluctuating prices or not, the market is now focusing on newest technologies and the ability to generate as much energy as possible from a project, much more than they used to do. If you remember back in 2012, 2013, 2014, maybe when poly and mono debate was there, people still used to go with polycrystalline because it was cheaper in price. But now we don't see that anymore. We see people pushing always for the newest technology, even in not very mature market as well. You go in markets that are still kicking off, and you see them asking for the highest power, the newest technology. And this is why Longi, when they started, they went only for monocrystalline. This is why Jinko Solar today is going for 100% N-type by the end of the year. So it is our duty, because we cannot control the prices, we cannot control the oil prices. What we can do to reduce the levelized cost of energy is to generate as much energy possible from a project. And this is where, in my opinion, the new N-type technology for solar modules is going to have a massive impact on reducing the levelized cost of energy. Before we close this, one simulation we did, a case study, we compared the 600 watt bifacial modules using single tracker with 650 watt from a different supplier, and we just checked that switching the technology and the impact that you're going to have on the module might decrease the levelized cost of energy of 5%. And it has been a long time since there was a technology that does this much impact on a levelized cost of energy. So definitely always go for the newest technologies. Now N-type TOPCon is without a doubt the next big thing in the market.
Thank you very much. Yes, N-type, and we are reaching 22%. Very impressive, Walid. On the note of generating as much energy as possible, like Walid said, I like to ask all the speakers this question about the newest technology that they advise their client to use in order to maximize the energy. Mr. Razwan, what is your insight? What is your recommendation for clients entering this market?
Yeah, so each market is let's say slightly different. So for the residential applications, we're seeing that a DC coupled energy storage and PV system is the most optimum way of harvesting the energy, whether it's coming from the PV and shifted over to the energy storage. So saving that conversion loss that is traditionally, let's say the mindset is going towards where you're converting it with a single inverter from a DC source to an AC source, and then you've got a battery inverter, which then converts it back from an AC to DC source. So overall, the efficiency losses are quite large there. So we suggest to go with a DC coupled for the residential. For the commercial, from the roadmap of products that are looking to be launched later this year, we are bringing commercialized energy storage to the market to a slightly larger capacity of around 100 kilowatts. However, that we do traditionally see as an AC coupled type of application, because the applications will be quite smaller compared to residential and utility scale. And as for the utility scale applications, we are launching our Fusion Solar 8.0, which is a bipolar 3000 volt architecture, which works with, let's say, the PV system working in the field and also energy storage working localized to where the transformer stations are and where the bi-directional inverters would be located as well. So this kind of solution and architecture streamlines that conversion loss, which is traditionally seen in energy storage plants for the utility scale, whilst also providing a more consistent power flow of energy coming out from the transformers. So rather than when a cloud coverage is coming over, there's a dip of energy, and that then impacts the electrical infrastructure. We can then stabilize and start working towards a more stable forecasting energy for the electricity companies itself. I'd like to just kind of conclude there. I've got to, apologies, leave a little bit earlier than the rest of my panelists. Thank you very much all for listening, and my contact details will be shared after today's session, along with the presentation as well, available to be shared as well. Thank you, and good afternoon.
Thank you, Rizwan, very much for your insights. Highly appreciated. Yes, we come back to our dear friend Radwan. Rawad, sorry. Rawad.
No issues.
Radwan. Rawad, how can you maximize the energy with your systems? Would you brief us, please? Thank you.
Basically, yes. So this is the technology or the solution that we provide. The main purpose is to increase the renewable energy penetrations. For sure, we differentiate between PV diesel genset and PV diesel genset with the battery storage. For sure, with the battery storage, we try or we can maximize the PV penetration, since all the surplus can be stored in this battery storage. For the PV diesel genset, we're a bit tight. We try as much as we can, let's say, to increase this penetration, and at the same time we need the safety of the genset. So this is why we provide the minimum genset loading. Below this percentage, you will have some additional fuel consumptions. I believe Syed more about these. So since Jubaili, they are the suppliers of gensets. So below this percentage, you will have some additional fuel consumption, and you will have in the long term some maintenance problems. So we're between, let's say, increasing the PV penetration for the system and at the same time helping or protecting the genset for a long term. For the battery storage, so our solutions are flexible regarding, let's say, the control strategy that we use. We have our engineers, our developers, in order to support and advise our client how to use, let's say, the battery storage in the best way, taking into consideration all the different sources available on site.
Thank you, Rawad, very much appreciated. The same question goes to our dear friend, Mr. Syed. Mr. Syed, what is your recommendation regarding maximizing the energy from the available products in the market, maximizing the renewable energy, of course?
I think there is a one-word answer: right designing. So basically, what we lack is the right sizing of the system. So there is no like, if you really want to save on the energy and you want to bring the levelized cost down, it's about the right size of the PV versus the right size of the genset, right size of the selection of the batteries. As Rawad was telling, that for example, you cannot have much more PV unless you have a battery, because the genset cannot take much of the power off to it. You have to have a minimum 25 or 30%, depending on the manufacturer, on the genset if it is a PV diesel hybrid application. Beyond that, you cannot go. Otherwise, there will be a slobbering, there will be a spillage, or there will be a high maintenance cost on the genset. So you have a window of that 70%, and that 70% means like you have to see that where the maximum curve of the maximum parabolic curve of the solar is hitting that 70%, because beyond that 70%, it means like you have the excess energy. Unless you have the storage, you cannot not store that excess power of energy and utilize. And the storage will always make sense if you have you are operating under certain condition, like high fuel price, maybe a low night load. So there is it's about the designing, to be honest. Like with the proper design, proper selection of the components, you can hit the right number.
Thank you, Syed, very much. Waleed, from your insight into, of course, the manufacturing, the engineering, the product development, what is your recommendation for maximizing the energy from renewables, from solar PV, of course?
Using Jinko Solar maybe as a start. Yes, sir. No, this is seriously a very good question, and especially the demand is very high, and again, people should focus a little bit more on the module, because at the end of the day, the module is what generates the electricity. Everything else is a way of adjusting or transforming or handling the electricity afterwards. So you need a reliable product. Again, for solar modules, it's very easy answer. You should always go with the newest technologies now. N-type TOPCon combined with half-cut, combined with multi-bus bar, provides a massive improvement on generation. I have done an exercise in Dubai, one in Oman, one in Saudi Arabia in the past 3 weeks, and every single time the extra generation switching to these modules, maintaining the same number of modules, is more than 7% overall, alongside the overall the lifetime of the project. It is important to focus also on what's going to happen to the project after a few years. This is why my colleagues from Huawei, of course, they provide a very high quality product. Elum does the same, Jinko does the same, and this is something that also should be taken into consideration when you choose your renewable energy system overall, or solar energy as a specific.
Thank you very much, Waleed. The Lebanon market was mentioned several times as a booming market. So I like to ask a question to all the speakers about recommendations for the Lebanese engineers in selecting their renewable energy systems. We start with Mr. Rawad. What is your recommendation for the Lebanese engineers in selecting, in designing and developing the renewable energy solar PV systems?
Okay, what I can say, and already Syed told, so is a good design. Basically, this is the key, and for sure, using the best solutions and reliable solution for the system to stay as long as they can, if I can say. For example, Waleed mentioned Jinko Solar as panels. So basically, the good design and let's say the installation, which is matter. Lebanon sometimes is a bit complicated countries in terms of installation. To be totally frank, I'm Lebanese. That's why I know about Lebanon and what is happening. So that's what I can advise. And for sure, I have several clients in Lebanon working on several projects. And now it's booming in Lebanon, especially with what's the situation and everyone trying to switch due to the outages that is happening there.
Thank you very much, Rawad. Highly appreciated. Mr. Syed, what is your recommendations for the Lebanese engineers in the booming Lebanon market?
I would say it is booming on the one side, but again, the situation is not that great. I will just continue to focus on the socio-economic situation of the Lebanese market. So you see, like most of the customers in Lebanon, they are depending on at the moment on the power from Ishtarak. Ishtarak is something like you get a community power from a rental generator, and there the price of the power is too high. And apart from that, they are facing the blackout of 6 to 8 hours a day. Maybe everybody agrees to me who are listening. The only solution at the moment for the people in Lebanon to just sustain with a better with the amount of electricity required to live a normal life is by switching to the hybrid systems. And the hybrid systems and the engineer need to be focused on multiple factors. Like first of all, the load analysis of the customer. Like in Lebanon, we majorly use the term in amps, and not as compared to the other markets where the kilowatt is the term. So basically, understanding of the amps and the kilowatt and giving it back to the supplier is very important. So the idea is to first of all choose the best component for a right selection. The major market is the residential at the moment. It's a major market in Lebanon, which is booming. So the right design means the right equipment, right engineers to design the right equipment. Sometimes we see that the batteries are being drained 3 times a day, like cycles 3 times a day.
Wow.
It depends on which battery technology you want to choose. Like for example, if the application requires 3 times cycling, certainly you need to switch to a newer technology, like for example lead carbon or lithium ion batteries, which can give you that amount of cycles. And then there is no such consideration on the temperature or the flow of the air for the batteries to breathe, I would say. So these are all the recommendations. Like when we do the systems, and especially in Lebanon, we try to take care of all these things, and not because again we totally understand the situation of a person over there, and out of no power or out of the issues with the infrastructure, he's switching towards the solar. So giving him the reliable system is I would say this is the utmost importance which the engineer has to give at the current time.
Thank you very much, Syed, for this insight. Waleed, do you have any recommendations for the Lebanese engineers in developing their market, in supplying the right equipment for their primary residential, I would say, solar PV systems?
It's a learning curve that has to happen in any market. I think Lebanon has absorbed solar energy this year more than they have done in the entire history of Lebanon. And it is very important to keep into consideration that when people buy this 3 kilowatt, 5 kilowatt hour, 10 kilowatt hour system, they put all of their savings usually in order to buy this system that is going to provide them with the basic electricity required. It is important. It is extremely important, especially in Lebanon these days, to consider these systems as a long-term investment. This is not a commodity. This is not a light bulb that you can replace if it doesn't work properly. Using technologies, using products that can survive 10, 15, 20, 25, 30 years as planned or as intended to be is extremely important. But unfortunately, I think in the next 2-3 years, we're going to start seeing a lot of failures because we have seen that this industry is not being treated as it should be in the complexity it is. And hopefully the learning curve will be faster because people, I don't think they can afford buying the same system every 2, 3, 4 years.
Thank you very much. My last question to all the panelists is about data management and control systems. Mr. Awad, what is your recommendation for the latest technologies in data management and control systems?
I can advise to use Elum. So that's what I can advise. So we have reliable solutions, we have the flexibility, we treat each project by project, and we give the best support. So this is what I can say, to use Elum Energy as this monitoring for sure. So regarding it's totally needed for the moment. All the APCs or the clients want also not the control, the monitoring is important because they want to monitor their site for a long time. They want to see what is happening on their site if there is any issues, and this is what we try to provide our solution, not only for a project for one time installation, but for let's say a long term to monitor, and we support even after a long time our client with these systems.
Thank you very much, Rawad. Highly appreciated. Mr. Syed, what is your recommendations for data management and control systems for your for clients? Do you have like international standards, best practices to adhere to? Thank you.
Thank you for asking this question. What we used to say in the data field, the data is the new gold. So what amount of things you can do with the data is immense at the moment in the industry. So what is the need of the hour, and what is the need of the time? It's like to have the connected assets. So this is what as an organization Jubeli is doing as well. Like we are connecting all our generators through the remote monitoring. So uh, it changed the entire approach towards the hybridization or the hybrid system. Once you have the fuel data regularly coming in, you can approach to the customer and tell him exactly like how much PV you need. Apart from that, you can go to the preventive maintenance techniques instead of the corrective maintenance. You know what is your mean time between failure, which customer needs the spare at what time, and this is all with the data. So unless you have like with an organization like Jubeli with the 20 gigawatt of operational assets across the world, we are heavily relying on these new IoT platforms which we are developing. Cloud computing is the next thing. You want that data to be stored in a lethal way, because all the customers, the data privacy is a key. Like for instance, like if you are operating any military site, you are operating any critical application site, this data requires a certain a certain amount of security. So with the data implementation or the IoT implementation, the very first thing which the customer asks is about the data privacy. So this is a very important topic, and definitely within our organization, when we are getting into these systems, which we are saying that our organization will be the data-driven organization. We take care of all these matters. That data is in a safe hand. It is stored properly. How to select to whom you have to give the data, like AWS. You have multiple data saving platforms at the moment. So yeah, it's a huge topic, but again, the world need to understand that data is the new gold, and on the data you can do anything you want, and especially in the renewable fields.
Thank you very much, Sayed. Waleed, and I'd like you to answer the question as well from your experience in design management and construction and business development right now. What is your recommendations for data and controls for the solar PV systems in less than in one minute or less?
Thank you. I actually do not have a recommendation, to be honest, Samir. I just people from Elum know better about this. Rawad can give a better suggestion, but it is extremely important to take this into consideration, because the complexity of renewable energy systems is becoming harder and harder. In the past, it was a simple on-grid, whatever is not used is exported to the grid. Now we are seeing PV hybrid, now we are seeing off-grid. So all of these small details is going to have a major impact on the performance of the project.
Thank you very much. At the end of this remarkable event, I'd like to thank our sponsors, Huawei and Elum, and our fantastic coordinator, SolarQuarter, Miss Priyanshi. Priyanshi, it's back to you. Thank you.
Thank you so much, sir. We have few questions from the audience. We can take one or two if we have time. That's okay.
Yes, okay.
So I'll display it on the screen.
Okay, what is the total charging discharging efficiency of battery storage subsystems in the total solution? Maybe Razwan was able to answer this, but maybe Mr. Sayed or Mr. Rawad, would you like to take a stab at this?
I'll take that question.
Sure.
So basically, the question is about the battery's round trip efficiency. So basically, the round trip efficiency of the battery is. Let me just explain it to you, like how it has been calculated. Basically, the amount of charge which the battery loses during the whole cycle of the charging and discharging is called its round trip efficiency. Generally, for the lithium, it's considered as a 10%. This terminology is much more widely being used in the lithium. And for the other batteries, it differs depending on the technology to technology. For the lithium, if I say it is around 10%.
Thank you very much. Thank you.
So I'll
Yeah.
take just one more question and then we can wrap up the session.
This question is for Walid. What do you think about the impact of new technology in PV will be on the existing solar plants after say 10 years? I can't read the rest of the question. Let's see.
So you can scroll down,
I hope I can
or I
scroll.
should
Yes,
read it
yes.
for you.
Yeah. Will this fast technology be able to support the old plants in case any issues? I think we understand what the question is about.
Yeah.
Walid, go ahead.
Yeah, it's basically the technology is improving very fast, and we understand that. And there is a big concern for people who install projects that what's going to happen after 10 years when my product that I have installed is not available anymore if I want to do any replacement or maintenance. And this is a valid point. But the good thing is that the technology is only improving. So if you use a newer module, uh, it's going to be compatible with your system because it's going to be overperforming. It's going to give you extra current, extra voltage, and your system can accept and limit whatever the units are. So basically, you can put a 500-watt module in the place of 400-watt module. And if Razwan was here, he would have wanted to mention this. This is something very important. This is one of the advantages of string inverters, is that if you have a problems, you can actually install a new string using a new technology completely. As long as it is put on a different MPPT, then the entire process is going to be good. So let's say you have a 100 kilowatt plant, you have a problem in 5 kilowatt out of them, you can simply rearrange the modules again and install a 5 kilowatt of the new technology modules at a separate MPPT, where the impact is going to be actually a positive impact, 100%.
Definitely, there is a room for engineering the old plants with the new solar PV technologies, and as long as we have brilliant engineers like our speakers, we will have solutions. Thank you very much. Back to you, Priyanshi.
Thank you so much, everyone, and a special thanks to Sameer sir. The way you combined the various interests of the industry and related those interests to the panel of experts and made the discussion very constructive. Your moderation of the panel was really brilliant, and I'm sure the audience really enjoyed listening to you all. Also, a very special thanks to our sponsors, Elum Energy and Huawei, for extending their support to this event. Thank you, everyone, for extending your time and support. We promise you to come back with more such exciting topics. Take care.
Thank you.
Thank you,
Thank you.
everyone.
Thank you, sir. Take care.